Of sines and cosines. As we saw in the last video, the law of sines is a proportion relating the sine of an angle to its corresponding side. And that proportion allows us to solve triangles that have a relationship of angle, side, angle, or angle, angle, side. It also allows us to solve side-side angle, but this introduces an ambiguous case where you could have no solution, one solution, or even two solutions. For this video, we're going to be looking at the law of cosines, which is the Pythagorean theorem of an oblique triangle. So the law of cosines actually comes in three parts, and it gives us an opportunity to solve triangles that have two sides and the middle angle, or where we know all three sides and don't know any of the angles. When we're dealing with the law of cosines, it can be written in three different ways depending on which angle you're choosing to focus on. So let's take a look at the formula for the law of cosines. So again, it's going to look an awful lot like the Pythagorean theorem. The only difference is that in an oblique triangle, you don't have a hypotenuse because you don't have an angle that's opposite of 90 degrees. So with the law of cosines, we can say that c squared is equal to a squared plus b squared minus 2ab cosine gamma. And what we're essentially doing is something very similar to the law of sines, where we took an oblique triangle and we broke it into two right triangles. And that's where the law of sines came from. Well, the law of cosines come from the same place. If you break it into two right triangles, this represents the adjustment or the oblique section of the oblique triangle. So again, this formula can be done from any angle's perspective. So this is from angle C because it looks the most like the Pythagorean theorem, but we can rewrite the equation with B and we can rewrite the equation with A. And basically, every time you apply the law of cosines, you are simply choosing which angle that you're going to focus on. So we'll solve two examples in these video notes. One where you know all three sides and you don't know any angles, and one where you know two sides and the interior angle. For the first example, we're going to let A equal 3.8, B equal 9.6, and C equal 7.7. So if we draw this triangle, again, I tend to default to an equilateral sort of looking triangle. We're going to let alpha, beta, gamma be here, and here are my three sides. When applying the law of sines, you have to have an angle and its corresponding side. And since we don't know any of the angles, we couldn't use the law of sines in this example, even if we wanted to. Instead, we're going to use the law of cosines. When we're using the law of cosines, we want to find the largest angle first. By finding the largest angle, we know that the remaining two angles must be acute, which allows us to eliminate any ambiguous case where we had one angle in the first quadrant that was acute and one angle in the second quadrant that is obtuse. By finding the biggest angle, we guarantee the next two angles are acute, and therefore we only have to focus on the first solution rather than finding potential extra solutions. For this triangle, that means we're going to be finding angle B first, since side B is the largest side. Knowing that we're finding angle B first means we'll set our equation with B squared is equal to a squared plus c squared minus 2ac cosine beta. B is 9.6, A is 3.8, C is 7.7, and we continue to input our values. Now from here, we need to solve this equation using our normal equation solving rules. The order of operation applies, and what we do to both sides will need to make sense. For example, we cannot combine all of these numbers all together, because this term, this is one term right here, has cosine beta, and this term, or these two terms, do not. So as we begin to simplify, we need to make sure that we're paying attention to algebraic rules of combining like terms and solving equations. I'm going to go ahead and type into my calculator 9.6 squared, which is 92.16. And then I'm going to type into my calculator 3.8 squared plus 7.7 squared, which is 73.73 minus 2 times 3.8 times 7.7 cosine beta. This is now a linear form equation where we have y equals mx plus b. So we can solve this using two steps. Subtract 73.73 from both sides. You get 18.43 is equal to negative 58.52. Divide by negative 58.52. So it's at this point where you may forget how to find beta. We're looking at an equation. We've gone as far as we can. How do you get the angle out of a trigonometric function? By using inverse trigonometry. Although the value on my board has been rounded, I am not using 3.315. I'm using the entire value that's been stored in my calculator. So I'm going to do second cosine of the answer. And I find that beta is approximately 108.4 degrees. We now have our first angle. From here, there are two potential approaches we could take. We can continue to use the law of cosines for each of the remaining angles, but now that we have an angle and its corresponding side, we can revert to using the law of sines to find alpha and gamma. Since the law of sines is a simpler formula, it's just a ratio between sides and angles, or a proportion between sides and angles, the law of sines tends to be an easier way to approach from here on out. We're going to say that sine of 108.4 over 9.6 is equal to, let's start with alpha, cross multiply, 9.6 sine alpha is equal to 3.8 sine of 108.4. Divide both sides by 9.6. Sine alpha is equal to 3.8 sine 108.4 over 9.6. I'm going to apply my inverse here at this step. And then type this in your calculator. The inverse sine of 3.8 sine 108.4 divided by 9.6. We get that alpha is approximately 22.1 degrees. And here again we have options. We can use the law of cosines to find the remaining angle. We can use the law of sines to find the remaining angle. But we also know that the triangle angle sum is 180 degrees. So if we just apply the triangle angle sum, we know that gamma must be 108 degrees minus the sum of 22.1 and 108.4. And so we know that gamma is approximately 49.5 degrees. And we have solved the triangle using the law of cosines. Let's do one last example. This time we're going to know the angle in between the two sides and see how that changes our use of the formula. So for this last example, we're going to say that B is equal to 5.8, C is equal to 3.6, and alpha is equal to 39.5. Let's solve this triangle. Alpha, beta, gamma, 39.5 degrees, 5.8, 3.6. So the way this has been set up, you can tell we want to focus on the angle alpha. You can also tell that we cannot use the law of sines. We know an angle, but we don't know its corresponding side. And since it's not a right triangle, we can't use the Pythagorean theorem to find the missing side. Instead, we'll say that a squared is equal to b squared plus c squared minus 2bc cosine alpha. A squared is equal to 5.8 squared plus 3.6 squared minus 2, 5.8, 3.6 cosine of 39.5. Now, in the last example, we had to look at our terms separately. This term had a variable and could not be combined with this term. However, in this example, this is all being evaluated. There are no variables, which means we can actually type this entire thing into our calculator at once. 5.8 squared plus 3.6 squared minus 2 times 5.8 times 3.6. Be sure that your calculator is still in degree mode. And evaluate. A squared is equal to, well, approximately equal to 14.376. Well, let's do 3770. I like to keep more decimals when I know that there's going to be another step. Because a squared is equal to, we need to take the square root of both sides. Just like before, I'm not taking the square root on the rounded value. I'm taking the square root of the answer that's stored in my calculator. A is approximately 3.8. I'm going to leave solving the rest of this triangle up to you because at this point we now have a corresponding angle and its corresponding side. So we can use the law of sines to find another missing angle, and we can use the triangle angle sum to find the third angle, just like we did in the last example. This is going to conclude the video notes for Objective 8, Law of Sines and Cosines. The corresponding chapters in your book are 5.1 and 5.2, so please start practicing your homework problems.